The Tyso Daiko is a dual 12-bit digital wavetable drum voice with an extensive tonal palette designed to produce greatly varied percussive and melodic sounds, both familiar and entirely unique. The dual voices share all primary sound parameters, but are independently triggered and pass through their own unique output stages, each complementing one another when stacked or used independently. Full voltage control and a unique combination of parameters makes the Tyso Daiko a fun and expressive, wide-ranging drum module. To start, let's take a look at the basic connections. The 4 inputs along the bottom are designed to accept trigger or gate signals depending on their function. The Daiko must always be triggered to produce a sound. Trig 1 will trigger the first voice, corresponding with output 1. Notice that output 2 also lights up when triggering voice 1. This is due to a normaling of the Trig 2 input to Trig 1 when nothing is patched. As soon as another source is connected to the Trig 2 input, the normal is broken and the voices play independently. The 2 voices share all the primary parameters. However, each includes a unique sound shaping stage prior to its individual output. Voice 1 passes through a voltage controlled analog tilt EQ, emphasising the lows or highs. Voice 2 passes through a wide-ranging digital wavefolder that reaches far into harmonic and noisy territory. The effects of both output stages are greatly varied depending on the source pitch and selected waveform. We will explore these sounds in greater detail later in the video. The accent input provides additional expressivity to the 2 voices. When a high gate is received, accent will double the release time of voice 1, whilst having the release time of voice 2. Accent allows for further separation between the voices and is useful for layering as one or common dual voice pairings such as a kick and snare or open and closed hi-hats. Next there is the choke input, which only affects voice 1. When a trigger is received, the audio from voice 1 is immediately cut off until the next time it is triggered. Voice 2 does not respond to signal at the choke input. Lastly, the volt per octave pitch input allows the Daiko to function as a melodic voice, bridging the gap between drum sounds and synth voices. The start frequency control acts as a standard pitch offset when the rate control is down. Both voices share pitch and respond to the volt per octave input equally. Let's take a look at the 3 main voice parameters that make up the basis of every sound. The release control sets the time of the exponential decay envelope. Release time spans from essentially producing no sound at the minimum setting to lasting several seconds when set to maximum. The envelope has a characteristically snappy sound tailored to creating percussive hits. Next is the surface control. When set to its minimum, surface is off and has no effect on the sound. Upon turning up the control, a resonant click is added to the start of each hit. Note that the length of the click is affected as release is shortened. As surface is turned up, the click becomes more mellow until the halfway point of the control is reached. From 12 onwards, surface becomes a slow attack envelope, fading in the sound before transitioning to the release stage. Note that the two controls now interact to alter the level of the voice. The source of every sound from the Daiko is its wavetable oscillator. The wave control morphs between 11 different 12-bit waveforms. Let's go through them, starting with pitched digital noise. The later waves are geared more towards producing cymbal and bell-like sounds. At higher pitch settings, a chaotic lo-fi aliasing occurs in these waves, aiding in the creation of unique effects and metallic sounds. As mentioned earlier, Voice 1 passes through an analog tilt equalizer. Let's explore its effects on some of the source waves. When the EQ control is centered, it has essentially no effect. As the control rises, emphasis of the spectrum is shifted towards lower frequencies, darkening the sound. As the control is lowered, the reverse occurs and higher frequencies are emphasized to give the sound a brighter timbre. The effects of the EQ heavily depend on the selective wave and pitch of the oscillator, as these directly impact the frequencies that are emphasized. Additionally, the EQ section includes an external input for processing and mixing in other sources with Voice 1. The most straightforward use of this input is to combine and EQ both voices together by simply patching output 2 back into the external input. This technique works especially well when layering the voices to create snare-like sounds with both a noisy and tonal element. Of course, any external sound source may be patched through the tilt EQ, and the Daiko does not need to be triggered to use it. Finally, the EQ section includes a CV input. If we patch an LFO, we can modulate the tilt frequency just like any of the other digital parameters. However, due to the EQ being an analog circuit, we can also modulate it at very high audio rate frequencies with an oscillator like the MCO. Modulating tilt frequency at audio rates is an interesting way to add additional harmonics to the Voice 1 output. Now let's monitor the output of Voice 2 and listen to the effects of the fold parameter on some of the waveforms. Like the EQ, the sound of the Wavefolder depends heavily on the selected source wave and its pitch. Generally, the fold parameter allows Voice 2 to function as a noise source if set to maximum, regardless of the selected waveform. This is good to keep in mind when combining the voices to create a single hit. Now let's take a look at the three pitch controls: rate, start and end frequency. As mentioned earlier, the start frequency simply controls the pitch offset when the rate control is fully counterclockwise. The end frequency has no effect until the rate control is turned up. Once rate is increased, a pitch sweep is engaged and the oscillator begins to travel between the two frequencies set by start and end controls. The time it takes to travel between the two frequencies is set by the rate control, with the speed increasing as it is turned up. The pitch sweep always runs freely but resets whenever the voice is triggered. We can reverse the direction of the sweep by starting at a low frequency and ending at a high frequency. At higher settings, the sweep time begins to reach into audio rates, acting as an internal FM oscillator that provides additional complexity to the sound. Let's explore some of the unique sounds that can be created using the pitch sweep. Naturally, the sweep works great when designing kick drums. If rate is set longer than release, the sweep will not loop within the time frame of the hit, thus sounding more like a typical pitch envelope. At moderately fast rates, the sweep can sound almost like an echo as well. Note that the two voices' pitch sweeps are triggered independently from one another, creating an interesting stereo effect when the outputs are panned. Many of the Daiko's parameters can be voltage controlled, taking it far beyond simple static sounds. Let's build up a percussive patch, starting with the 2 trigger inputs, then utilising the accent and choke inputs to emphasise their rhythms. Next, we'll modulate fold with a gate from PAM, followed by another gate to increase the rate of the sweep. We can increase the sharpness of the attack by adding a click with the surface control. Let's add some audio rate modulation to the tilt frequency with the MCO. We'll patch its main out through a channel of tangle to fine-tune and control the modulation level with CV from the pip slope. Now let's modulate start frequency, which affects the behaviour of the pitch sweep, interacting with both the rate and end frequency settings. Keep in mind that all the controls function as offsets, with the incoming CV added to their positions. They may need to be adjusted accordingly once modulation is patched. Let's repatch voice 2 through the EQ section and emphasise the lows of both voices. We can remove the gate triggering choke on voice 1. Let's add some modulation back to the start frequency and increase the rate control to reach into FM territory. Although the Daiko works great as a static sound source, adding movement via CV modulation almost always leads to more expressive and exciting sounds. Let's take a look at some larger patches. In this first patch, the Daiko's pitch sweep is used, along with a rising ramp wave to the volt per octave input to create bubbling effect sounds. Let's bring in voice 1 followed by voice 2, which is sent through a small room reverb via the SBG. Although the frequency controls are shared, each voice's sweep is independently re-triggered, creating further separation between them. Let's patch gates to the rate and start frequencies to jump between slightly different sweep settings. Like before, we'll modulate tilt with the MCO, but this time at a lower frequency to add a subtle motion to voice 1. The Tyso Daiko can be used to create all sorts of melodic and percussive sounds, many of which sit somewhere in the middle, working great in a mix alongside more traditional drum machines and synth voices. In this patch we have designed a full drum kit with the Daiko, pre-sampling 8 different one-shot sounds into the squid. Let's build up a simple beat using the samples. Now we'll trigger the Daiko live, adding it back as a melodic percussion track to complement the beat. Sampling hits from the Daiko is a great way to design inspiring custom drum kits and further manipulate its sounds. In this final patch we are using the Tyso Daiko-like synth voices with a quantized melodic sequence from PAM. By raising the surface control, we can add a slower attack envelope to fade in the notes. Let's darken the first voice using the tilt EQ, then mix in the second voice that alternates its triggering with the first. We'll also add a snare from Akemi's Taiko. Patching a smooth random modulation to the folder mount will add subtle harmonic changes to voice 2. Let's mix in a complementary melodic voice from the castle. Using another smooth random CV from PAM, we can modulate the wave selection. Now let's transpose the PAM sequence controlling the castle using the Quade Megaslope. Finally, we'll transpose the Daiko sequence up an octave and shorten its release time. Thanks for watching this video of the brand new Tyso Daiko dual wavetable drum voice. As always, subscribe to stay up to date with new videos and product announcements. For more information about the Daiko and the rest of the ALM product line, please visit busycircuits.com.